Today's lesson's on slope fields, and I decided to try a different method today. So you can see my hand moving. Anyway, and this is how we did them last year when the COVID hit, and I forgot. I kind of like this way better. Anyway, the goal today is to solve differential equations, okay, or find a differential equation. Now, a differential equation, as long as it has a derivative in it, you've got it. So I have 2x plus 3. Well, I know if I integrate 2x plus 3 with respect to x, I get x squared plus 3x plus c. And I know the answer. I solved for y. All right, the problem is sometimes, like in our first example down here, you've got a y and an x. I don't know how to differentiate that. This one's got an x and a y in it. I don't know how to integrate that. I will on our next lesson. I'll teach us how to do that. So what we use is slope fields. It's a graphical approach. It helps us find the what the original function is. Euler's method, this is a BC, so we're not going to do that. I'm going to cross this out because it's not true. It's supposed to be vertical and horizontal, and it's not true and doesn't really make any sense. So we don't need that. Now, the rest of it is what you do is you are making a field. I'll show you. It looks like one of these, this one right here. And what those are itty-bitty tangent lines to the parent graph. So what you do is you plug in values of x and y, and you can make this chart, fill them in if it's easier. I like to start, these are my x's, these are my y's. I plug the 0 in for the x, and so all you get is the opposite of y. So this is -2, -1, 0, 1, 2. And then I go up here and I draw a little tangent line with a slope of -2. And here's a slope of -1. Oh, I'm in the wrong spot. This is -2. This is -1. This is 0. This one's 1. This one's 2. You're just guessing. Is it close to 2? All right, now if y is equal to 0, you got just the x value. So that's down here. So this one's -2, so it's a little steep. This is the 45-degree line. We already did that one at 0. This one's 1, and that one's a little steeper at 2. Then you can fill in some of the rest. All right, so if my y value is 2, you have -2 minus 2. This is -4, -3, -1, and this is 0. So up here at 2, 0, this is 0. A -1, -2, -3, -4. Fill in this line. I already know these, so I'm going to do them very quickly. I know this is there, and that's a 1. This one's, we did -1. So this is -2, -3. And we got that line. This is -1, 0, 1, 2, 3. So here's my 0 again. -1, a 2, and a 3, and 0, 1, 2, 3, 4. Okay? These are not hard. They're just tedious. They drive me crazy. I hate making them. But from that graph, I can find the parent function, the original function. The problem is we don't know, is it coming down here? Is it coming down this way? Is it coming down this way? And what's making that difference? Well, the difference is this C right here, right? And we don't know what C is, so we don't know where the graph is. All right? They're just tedious. This one, we can do this. It's kind of important. If you let x be 0, all of these are 0. So this goes like that. If y is 0, it's undefined. Well, an undefined line is vertical. So those are all vertical. And I guess this one we should erase because 0 over 0 is not there. Okay? Now, if x is 1, 1 over 1 is 1. Oh, this is 2 over 2, 3 over 3. So those are all slopes of 1. These are all slopes of -1. Okay? Am I making you sick? It keeps rolling around. All right, now I'm going to have 1/2, so that's a half. 1/3 is a third. This is 1/2, so it's a -1/2 and a -1/3. I have 2/1, so that's steeper. I have 2/3, so it's here. I have -1/2 is -1/2 and a -1/3. Here it's -2/1, -2/3. And you can see that your graph looks like it's coming in this way. The same thing continues down here. And you can figure out the parent graph. Ones with only one variable, this one only has an x in it. If x is 0, these are all -1. If x is 1, these are all zeros. If x is 2, these are all 1s. Sure looks like my graph is doing this. Well, integrate. Integrate x minus 1 with respect to x, and you get x squared over 2 minus x. Sure enough, it's a parabola. Okay? This one asks you to draw it through a specific point. So again, if these are zeros, so 0, 0, I have 0 plus 1, 2, 3. This is -1, -2, -3. If y is 0, this is -1, -2, -3, +1, 2, and 3. Put in 1, 1, you get 2. 1 in is 3. 1 in 3 is 4. 2 in 1 is 3. All right. So where do we get zeros? Well, one's positive, one's negative. It's going this way. I need to go through this point, so let's do one of these. I have 1 minus 2 is -1. All right, so what's my graph doing? Well, is it coming down this way? I don't know, maybe going like this. And it has to go through that point, and that's what they're going to look for. Now, maybe you drew yours going this way further. Maybe you drew it going this way further. They're all acceptable. I very rarely fill in the chart. Okay, now this needs to get across. Well, come up. It says the slope field for a certain differential equation is shown below. Which of the following could be the specific solution to the differential equation? So the solution, specific solution, is a y equals. It's the main function. Well, if you follow these slope lines, it looks like it's going like that. Right? Remember, these are tangent to the graph. That looks like an x cubed. This one's a little confusing, but one thing you need to change on this AP question, it says the slope field for a certain differential equation is shown below. Which of the following could be, and cross out the specific solution and say the differential equation. So what graph did they graph here? All right, so then you look at it and you go, well, these look like they're all 1s. These look like they're all 2s. These look like they're all 3s. Here's all -1, so they all represent the y value. So here's your answer. That was wrong on my first video. And that's all there is to slope fields. There's always one on the AP exam because they can have you sketch it. They can have you find the parent function. They can have you integrate it. You can find the derivative function. You can integrate, and then they can do an application problem.